equivalent to saying for every epsilon positive, there exists a delta positive such that every time we pick x close to 5 less than delta, it will always imply that the function minus the limit will be less than epsilon. So I start here. So 3x minus 15 less than epsilon. Factor out 3, but I have to write it like this first. Remember, this is what I'm after. This is what I want here. I have to show the property. This is mandatory. Don't just divide by 3. You have to show this step. You have to change that into 3. The absolute value of x minus 5 less than epsilon, and the absolute value of x minus 5 less than epsilon over 3, and this must be the delta we are looking for. So this will be part A, and in part B you're just going to write one sentence, reverse the steps to show that epsilon over 3, to show, but you don't have to actually do it, that delta equals epsilon over 3 works. And you don't have to actually perform those steps. Is this what you are looking for?
Yes.
Are all steps clear?
Yeah, I just wanted to refresh on it.
Oh yes, of course. Of course. Any questions, anyone? Next topic? Anything?
I guess I have another one.
Yes, I'm ready.
This was on the substitution rule.
Yes?
Alright, so it's evaluate the indefinite integral x plus 4. It's like in parentheses and then square root of x 8x plus x squared dx.
Excellent. So, see, this is my problem. Because the square root of a plus b cannot be simplified. This is it. Carved in stone. No one can do anything to it. So, I would like to work on this piece. So, I'm going to say let y be 8x plus x squared. But I cannot change the integral into y as long as, unless I have dy. So this will be 8 plus 2x. Of course, I cannot forget dx. And I notice something here. If I factor out a 2 and put in the correct order, I'm in business. This piece with this piece with a 2. Okay, not a big deal. So then I have 1/2 in front. This is the square root of y. This piece is the square root of y, all this. And the 2 and the x plus 4 and the dx, they're all in dy. So this is here. 1, 2, 3 are here. 1, 2, 3 here. So this is y to 1/2. So this is 1/2. Y to 1/2 plus 1 over 1/2 plus 1 plus a constant c. I flip, so I get 1/3 because it's 1/2 times 2 over 3. And this is the square root of whatever y was to the 3rd power plus a constant c. Very nice problem. Other questions? Anything else?
I guess I have another one.
Yes, I'm ready.
It's a Newton's method problem.
Yes?
It was to approximate this number. It was the square root of 77. There's like a 4 in front of it. Like it's like 4 square. Yeah.
Yes, very good. Okay, perfect. So this situation really has to be changed into a function. Okay, so if I don't have a function, how can I approximate that? And what function will have a solution like this? An equation. What function, what equation will have a solution? And if I talk about a function, this is an x-intercept. Either a solution of f of x equals 0, or an x-intercept of f of x. But I have to come up with something. If I don't have a function, remember, Newton's method is something like this. X minus f of x over f prime of x. So I have to have f. If I don't have f of x, I don't have f prime, and I cannot determine anything. So let's make something up. And that will definitely be x to the 4th equals 77. Why? Because when I take the 4th root, I get x equals the 4th root of 77. So I got my function. This is my f of x. And my f prime will be 4x cubed. So then I have the Newton's method that I'm going to put in the calculator like this. This over this. And I will definitely not start with 0. It will be a tragedy. Okay? So I have to find an interval. I will do that. Right now I'm going to share my screen. Very nice problem, thank you. Okay, in y equals, I'll clear my functions here. So I go back, and we had x to the 4th. I just want to take the square root of 77, the 4th root of 77 to see what it is. Because that's where the intersection will be, and that's how I find the interval. Okay, so it's 2.9. So if I start at 2, if I start at 3, it doesn't matter. Okay, so where do you want to start? You want to start, you can start at 2.5 if you want. It doesn't matter. You can start at 3. You can start at 3.2, right? Since this is a solution, I will double check. Okay, so to the left of the solution is, because I have to write the intermediate value theorem, right? That's the first step. So I have x to the 4th and minus 77. Oh no. Good. And I go to second and table, and I know if I plug in 2 and if I plug in 3, it must be a solution right there. So I would write that f of 2 is less than 0 and f of 3 is greater than 0. I'm going to stop sharing for 1 second. I'll come back to it. So at f of 2, I found that the function is less than 0. At f of 3, I found that it's positive. And f of x is continuous on 2, 3 for sure as a polynomial. Then, by the intermediate value theorem, there exists a c in the interval 2, 3 such that f of c is 0. So I justified all my work. I justified why I start where I start. So where do you want to start? Do you want to start with 2, or you want to start with 3, or you want to start with 2.5, whatever?
I guess 2.5.
2.5, perfect. So we want to start with x0 as 2.5, and we have to find x1, x2. How many decimal digits do they want? Just
correct to 8.
8, perfect. Okay, 8 decimals. Okay, so I'm gonna share my screen again and copy the function. So back to y equals, do not delete anything, just insert x. It's not a big deal, you can delete if you want. Minus parentheses, because that's the numerator already. Close the parenthesis, divided by, you know me, I have to have parentheses, and if without parentheses around 4x cubed, you're not going to get the answer. 4x to the third, close the parent. No, not there. Okay, here. Good. Am I correct? Yes, I am. So I get out of there and I go to variables. I choose variable 1. That's where my Newton's method is. We decided to start with 2.5. And then I copy. Do not get scared that it jumps a little bit. It's possible. But if it goes from 3 to 5 to 10 to -3 and -1, something is terribly wrong. Okay? So it has to get closer and closer to this number. So now, second, and I copy the entry. No, I didn't mean that. Second, I copy, no, that's not what I meant. Okay, so now I want the calculator to use the previous answer. And make sure you clear everything else from there. So now we plugged in 2.5 in the function we got. Let me write this down. So the first x1, the first iteration, 3.107, fine. And here's our second one. And that is 2.9720600731. And now all I have to do is just second and entry. Okay, x3. 2.9623050043. And let's see the next one. Okay, x4, 2.9622566639. This should be it. Yes. 2, 4, 6, 8 digits. So I will not copy x5. Is this okay?
Yes.
So this is it. 2, 4, 6, 8. You can round it up if you want. Good.